This is a video for AQA Discrete Mathematics. This is Critical Path Analysis section 1.2, where we're looking at how we analyze an activity network. Well, we saw that in the last video we could turn a precedence table into an activity network such as the one below, where the activities are labelled on the nodes, and the middle box underneath the label is the duration of each activity. Now we can analyze this network in several ways, and for example the basic things we can do are to find the earliest time that an activity can start and also the latest time that it can finish without delaying the project completion. So the outer boxes, on the left hand side we have the earliest time an activity can start, and then in the right hand box the latest time that it can finish so that the project itself is not delayed. Now these are the basics, and once we've got those we can then go on to find what are called the critical activities and what's called the critical path through the network. And very important in production planning are those two things. Which activities have to be concentrated on because they're so critical that any delay would cause a project to run late, and also then there will be a path of these critical activities right from the beginning to the end. So very important for production planners to have this sort of information at their fingertips. So the first thing we're going to do today then is to look at how we find the early times and the late times for each of the activities. Well, the early time is found by doing what's called a forward pass through the network, and then once we get to the end of it that shows us how long the whole project will take, or at least the minimum time that it will take, as long as there are no delays in those critical activities. Once we've completed that, we can then perform what's called a reverse or backward pass through the network to find the latest finishing times. So what I'm going to do now is go through that network that we had here and show you how we perform the forward pass and then later the backward pass. The activities at the start, well, they can all begin at time 0. So we start off by putting 0 in to A, B and C. Then consider going on from A. If the duration of A is 10, then that means we can reach D after time 10. So as long as there's no delay in A, and that's what we're assuming here, that there are no delays, then D can start at time 10. So the earliest that D can start is time 10. And similarly, E can start at time 9 because B has a duration of 9. Now we're going to go forward and look at F. You see that there are two arrows coming into F, one from D and one from E. So if you consider D, then D is 2 units of time in duration, so that would take us up to 12, 10 plus 2 being 12. E is also duration 2, but it can start at time 9, so that we then reach 9 plus 2 is 11. So that means that the earliest that F can start is 12. It's the greater of those two things. We've got 10 plus 2 is equal to 12, and 9 plus 2 is equal to 11. So the earliest they can start F is at 12. It's the larger of these because D and E have both got to be finished, and the earliest that that can possibly be is at time 12. Now for G and H there's only one arrow coming in, so we haven't got a great deal to think about really, just going from F. 12 plus 1 is 13, so that both G and H earliest start times are 13. Now looking at I, again only one arrow going into I, so that must be 13 plus 1 from G, giving you 14. J's got 2 coming into it though, so we've got to go right back to the beginning to C and see that 0 plus 3 is 3, but 13 plus 3 is 16. So therefore J, the earliest it can start, is at time 16. Now working to the end point, from I, 14 plus 2 is 16, and 16 plus 1 is 17. Remember, we want the largest time because that's the earliest that we'll get to the end, so the earliest that we'll get to the end is 17. So when you're working forward, if there's one arrow coming into a node, then it's straightforward. You simply take the node, the preceding node, and add together the early time from that one plus the duration. For example, at H we had 13 there coming from 12 plus 1, simply because there's only one arrow going into it. If there's more than one, you must look at the largest of the numbers that are coming into that node. There's a nice neat version of it. You can see then, so the minimum time at the end of completing this project is 17. Now once we've got the minimum time at the end, we can work backwards and look at, well, what's the latest time that the activities can finish so that the project is not delayed. So to do that, we start off at the right hand side. In other words, we go from the end and we work backwards. So the end time here is going to be 17, and then working back, well, we take 17 from 0, and again they've got this idea if there's only one arrow coming into a point, so I, working backward, there's only one coming into there, so it must be 17 and 0. That can finish at time 17 and there won't be a problem, and of course J is also 17. Now going back from I to G, we've got 17 minus 2, so think about that. Here we've got 17 minus 2 is 15, so we're subtracting this time, and there's only one arc coming into G, therefore that will be 15. Similarly for H, there's only one arc coming into H from J, so 17 minus 1 is 16. And while we're there, we can also come all the way back to C. 17 minus 1 for C is 16. Right, now we come to F. If you look at F, there are two arcs coming to F, one from G and one from H. So from G we've got 15 minus 1 is 14, and from H 16 minus 3 is 13. Now this time when we're working backwards we want the smaller of these, so this must be 13. Now the reason for the smaller is that because if that finishes at 13, H can start at 13, and away we go. If it finished at 14, G and H are going to, well, if it finished at 14, I beg your pardon, G would be okay because we'd have here 14 plus 1 is 15. So G we'd get away with, but H would be delayed because if this here was 14, then we'd have 14 plus 3 for H is 17. So H is going to be delayed. So you must go for the smaller of the numbers, the 13. Right, working backwards now, there's only one arc coming into D, so 13 minus 1 is 12, and 13 minus 1 for E is also 12, and then again working backwards for A, 12 minus 2 is 10, and 12 minus 2 is 10 for B. So that completes then the reverse or backward pass through, and there we are, and there's our completed activity network with all the numbers and all the information put into it. So just going through then that again, the boxes, the left hand one is the earliest time an activity can start, and the right hand one is the latest time that it can finish. So that then allows us in the next video to look at what are called the critical activities, but I'm going to leave that for now and just look at one more example and work through. So here we are, a second pass, second time through on a different network this time. So doing a forward pass from A, 0 plus 4 is 4, so going into C, that is 4. Into D we've got to check both. There are two arrows coming in there, so one from A gives us 4, 0 plus 4. One from B, 0 plus 2 is 2. So remember, we want the largest of those, 4, and for E that will be 2. Now for F, at the top there are two arcs coming in, one from C, 4 plus 3 is 7, and one from D, 4 plus 6 is 10. So the largest of those is 10. For G, there's only one arc coming in, so it must just come from D, 4 plus 6, 10. And then going down to H, 2 this time coming in, one from D at 4 plus 6 is 10, and one from E, 2 plus 4 is 6, so the largest of those is 10. Now working to I, this time looking at the two arcs coming into I, one from F giving 14 and one from G giving 15, so the larger of those, 15. And then to J, again 2, one from G, 15, and one from H, 17, so 17. And then finally to K, two arcs giving us 20. Now it's possible that we don't actually need an end here, but because there's only one arc, K is in effect the end, but you could put an end point in if you wish. The activity has 0 duration, so the earliest you're going to get to the end is going to be the 20 plus 2, which is 22. Now the reason it's not strictly necessary is because when we're working backwards from the 22, 22 minus 0 gives you 22 there. So really we're just saying that K, the latest it can finish is 22. So really that section there is just a repeat of that bit there. So it's not necessary, but you can put an endpoint in if you wish. Now working backwards then, we're subtracting this time. Remember, there's only one arc going into I, so that must be 22 minus 2, so subtracting gives us 20, and similarly for J, 20. Going to the top at F, again only one arc, so 20 minus 5 is 15. For G, there are two arcs coming in, one from I, 20 minus 5 is 15, one from J, 20 minus 3 is 17. So we want the smaller of those. Remember, this time we're working backwards, so we're looking for the smallest number, 15. Only one going to H, size 17. Now working to C, from F there's only one, so 15 minus 4 is 11. And into D there are 3 that we've got to check. From F, 11, from G, 10, and from H, 10. So the smallest of those, 10. Into E there's only one, so it's 17 minus 7, from H, 10. And then finally working backwards, from C to A would give 8, from D to A gives us 4, so that will be 4. and finally B 4 from D and 6 from E. So there we've got a lower value of 4. Well, once we've done our analysis, we might ask a question. For example, we might say, what's the latest time that C can finish if the project is to complete it in the minimum time? Well, we can see that directly from the diagram, and it's 11. What about what's the earliest time? Sorry, what's the latest time that C can start if the project is to complete it on time? Now you can see that it's got to be finished by time 11. And if it's got duration 3, it could possibly start at time 8 and still be okay. So C's start time is anywhere between 4 and 8. It's possible to start C at time 7 and still have plenty of time to complete the project on time. So C is an example of an activity that we refer to as having some slacked time. It's a non-critical activity. We're not tied to its start time rigorously. However, if we looked at G, for example, you can see that G must start at time 10 because 10 plus 5 is 15. It's got to be finished by time 15, so there's no slack there. If it started at time 11, it would be overrunning, so therefore everything would then be delayed. I would be delayed. So G is an example of a critical activity. Now in the next video we'll look at that in more detail.